So students, today we start the topic that is Newton's third law of motion, and we have complete up to the Newton's second law of motion. So today we start about the Newton's third law. The statement of Newton's third law of motion is that to every action, there is an equal and opposite reaction. The statement means that every interaction, there is a pair of forces acting on the two interaction objects. The size of forces on the first object equal the size of the forces on the second object. The direction of force on the first object is opposite to the direction of the force of the second. So forces always come in pairs, equal and opposite reactions. So the statement of Newton's third law of motion is to every action there is an equal and opposite reaction. To every action there is an equal and opposite reaction. Action and reaction are just forces. The forces always occur in pairs. Action and reaction do not act on the same body. Action and reaction are on different bodies. Action and reaction act on different bodies but simultaneously. So action and reaction forces are equal in magnitude. Action and reaction are equal in magnitude, but they do not produce equal acceleration in the two bodies on which they act. So action and reaction forces are equal in magnitude, but they do not produce equal acceleration in two bodies on which they act. Here I am showing that the two action F forces, action and reaction are shown here. Two springs are example application of Newton's third law. One reaction is 58 gram weight key. Then it is equal and opposite, therefore no change are shown here. Action and reaction. If we put a ball on the wall, then it goes to the wall and then comes to in our hands. That is equal and opposite reaction. For example, if you fire a gun, then the bullet goes ahead and your gun goes the backward reaction and gives a backward jerk, that is known as recoil of a gun. That is also according to Newton's third law of motion. The rocket going on the up on the air in the sky, and the gases go downward, and that is also on the Newton's third law of motion. That is identify action and reaction. Here action is the rocket is going up and reaction is gases going down. How we can walk on the ground, that is also the forward reaction and backward reaction. The reaction is weight on the ground, then action and horizontal component of the reaction, then vertical component of the reaction, then weight, and then we go ahead, that is the forward reaction. Action and reaction are also shown in a boat. If we push the water, our boat goes ahead. If we push the water, if a man sitting in the boat push the water backward, then the boat goes in the forward reaction. That is also on Newton's third law of motion. How a horse can pull a cart. A horse is urged to pull a cart. The horse refuses to try, citing Newton's third law as the defense. The pull of me on the cart is equal but opposite to the pull of the cart on me. If I can never exert a greater force, action and reaction are always equal on the cart than it exerts on me, how can I ever set the cart moving? So how would you reply? Why do not you educate the horse properly? Weight of the cart, HWC, is balanced by the reaction or reaction on the cart offered by the ground. Forward pull of the horse on the cart is balanced by the reaction pull of the cart on the horse. If the horse pushes the ground in a slanting manner, action, the reaction offered by the ground is resolved into the vertical and horizontal components. It is also a very important question in your NCERT book, how a horse can pull a cart. You must write it. The vertical component V balance the weight of the horse. If the horizontal component WH, H is greater than the friction force, then the horse cart system will move forward with the acceleration. Law of conservation of momentum. When two or more bodies act upon one another, मान लो दो बॉडीज एक दूसरे पे एक्शन कर रहे हैं, देयर टोटल मोमेंटम रिमेन्स कांस्टेंट प्रोवाइडेड नो एक्सटर्नल फोर्स आर एक्टिंग ऑन इट। अगर कोई एक्सटर्नल फोर्स ना एक्ट करे तो जो मोमेंटम है वो कांस्टेंट रहेगा, देयर एक्सटर्नल मोमेंटम रिमेन्स कांस्टेंट। Suppose a big and small car move in the same direction with different velocity. Let the mass of the bigger car will be m and its inertial velocity will be u. Let the mass of the smaller car will be m2. The bigger car mass is m1 and smaller car mass is m2 and its initial velocity is u2, such that u2 is less than u1. Suppose both the cars collide for a short time t. Due to the collision, the velocities will change. Let the velocities after collision will become v1 and v2 of bigger car and smaller car. Suppose that during collision, the bigger car exerts a force F on the smaller car, and in turn, the smaller car exerts a force F2 on the bigger one. When the two forces F1 act on the smaller car, its velocity changes from u2 to v2. F1 is equal to m2 a2. Then F1 is equal to m2 into v2 minus u2 by t. When the force F2 acts on the bigger car, its velocity becomes F2 is equal to m1 over a1. F2 is equal to m1 into v1 minus u1 by t. According to Newton's third law, F1 is equal to F2. To every action, there is an equal and opposite reaction. F1 is equal to F2 but opposite in the action. Here we can put the value of F1 and F2. We can cancelling t on both sides. We get m2 v2 minus u2 is equal to m1 v1 minus u1. M2 v2 minus m2 u2 is equal to m1 v1 minus m1 u1. Here you can change it. M1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Total momentum before collision and total momentum after collision. Total momentum before collision and total momentum after collision. Initial momentum of the bigger car is m1 u1. Initial momentum of smaller car m2 u2. Final momentum of bigger car m1 v1 and final momentum of the smaller car is m2 v2. It remains same after the collision. The total momentum remains same after the collision. That is the Newton's or the law of conservation of momentum. Recoil of a test tube activity. Here the event opposing up the cork. Here the event opposite up the cork is considered as a collision. Total momentum before collision is 0. Total momentum after collision also must be 0. Hence the velocities of the test tube and the cork are adjusting themselves. तो इसमें टेस्ट ट्यूब और कॉर्क की वेलोसिटी अपने आप को एडजस्ट कर रही हैं. दैट इज द कॉर्क एंड ट्यूब fly away in the opposite direction. Also note that the velocity of the cork lighter is faster than that of the test tube is heavier. Test tube is heavier. This is all about the Newton's third law of motion and Newton's third law of motion and also the law of conservation.